Hello, in this video we are going to look at how you rationalise the denominator when you have more than one term in the denominator of the fraction. So just as a recap, up until now we have had, for example, 1 over root 3, and to rationalise this we multiply this fraction by the denominator of this fraction, but both top and bottom. So effectively this is still 1, so we're not actually changing what the fraction represents. So this will become 1 times root 3 over root 3 times root 3. And remembering the rule that root a multiplied by root a is still equal to a, this gives us root 3 over 3. So as before we had an irrational number in the denominator, now it is rational, so we have rationalised the denominator of this fraction. Okay, so now let's move on to a case where we have two terms in the bottom, or as the denominator, where one term is rational and the other term is irrational. So how do we go about rationalising the denominator in this fraction? So remember, we want to remove all the root terms in the denominator of this fraction. Okay, so the process will still be similar in that we multiply it by another fraction, and then from that multiplication we should be able to get rid of this root 3 term. So let's just consider the 2 plus root 3 but within a bracket. Okay, so we're starting off with 2 plus root 3, and we need to multiply it by something, so something in another bracket, that should hopefully remove these root terms. So from multiplying out brackets, the first term is multiplied by the first, then it's multiplied by the outer term, then it's the inner, and then it's whatever's last, whatever hasn't been multiplied by. So if this is new to you, just remember FOIL, so first in the brackets, O is outer, so the outer terms, I is for inner, so the inner terms, and L is for last, so the last terms. Okay, so this would give us 2 multiplied by some number here, plus 2 multiplied by some further number here. Root 3 would be multiplied by this, and then root 3 would be multiplied by whatever's last. When we multiply it out from this fraction, we would end up with plus some digit in front of root 3. So in order to remove that, we need a minus sign. So however many positive root 3's we have, we need minus root 3's to remove it. So we'll put root 3 there. So for example, if 2 would be multiplied by this number, 2 would then be multiplied by this, so we'd get minus 2 root 3, plus root 3 would be multiplied by this, and then plus root 3 times minus root 3 would be minus 3. So in order to remove the same number of root 3's, we would then need 2 here. And I'll show you how it's easier to show this if I multiply this out. So following FOIL, 2 times 2 would be 4, minus 2 root 3, so that's from this arm. Then we'd have plus 2 root 3, plus root 3 times minus root 3 would be minus 3. So you'll notice within the centre of this expression, we have minus 2 root 3 plus 2 root 3. So this effectively would equal 0, because they'd cancel each other out. So we actually end up with 4 minus 3, which equals 1. And it is this fraction here, or sorry, this bracket here, that we multiply this fraction by top and bottom. And you'll notice that if I rewrite it here neater, we've got 2 minus root 3, 2 minus root 3. So this is still 1. all we have done is we've copied this denominator, but we've just changed the sign in front of the root term. So if this was minus, this would be plus, but in this case this is positive, so this is negative. So if I write this out up here, so following our laws of multiplying across fractions, so the numerator of the new fraction would be 2 root 3 all over 2 plus root 3 minus 2 minus root 3. Now the top would be equal to, so 2 times 2 would be 4 minus 2 root 3 all over. Now we did this expression down below. So 2 plus root 3, 2 plus root 3, 2 minus root 3, 2 minus root 3, and that gave us 1. So this actually equals 4 minus 2 root 3. And we have rationalised the denominator, whereas previously we had a root term in the denominator, now it has been removed. Okay, so a few more processes in rationalising the denominator where you have two terms in the denominator. So it might be best if I go over another example, and hopefully this should make it a little bit more clearer for you. So in this example we have 3 over 2 minus root 5. Okay, so we multiply this by another fraction, but this time we have 2 plus root 5 for the denominator and the same for the numerator. So again, this is equal to 1, so we're not actually changing the fraction. And I've obtained this because the denominator we're rationalising is 2 minus root 5, so all I do is change the sign in front of the root. So this will equal 3 would be multiplied by the top, so it's just easier in this case just to write 3 brackets 2 plus root 5 all over 2 minus root 5 2 plus root 5. So the top, 3 times 2, 6 plus 3 root 5. Now for the bottom, so remembering FOIL, so F for first, so the first would be the first digit in both brackets, so 2 times 2 is 4. 2 times plus 5 is plus 2 root 5 minus root 5 times 2 is minus 2 root 5 and minus root 5 times plus root 5 is minus 5. Again, from the rule that I went through at the start of this video, where root a times root a equals just a. But remember, if there's a sign difference, then the sign must follow through. So this equals 6 plus 3 root 5 all over, these cancel out because plus 2 root 5 minus 2 root 5 is 0, 4 minus 5 is minus 1. Okay, so if you wanted to simplify this to remove this minus 1 from the bottom, you just change the signs in the top numbers or top expressions. So we'd have minus 6 minus 3 root 5. Okay, so what I'll do, as with my other videos, I'll put an example down here. So in our example we will have 1 over 3 minus root 7. If you'd like to pause the video, give yourself a chance to do this question, then unpause and we'll go through the answer. So now it's unpaused to go through the answer of this, so we need to rationalise this fraction here, so it's basically we're rationalising the denominator. So we multiply this by 3 plus root 7 over 3 plus root 7 This 3 plus root 7 has come from the denominator here, but we've just changed the sign in front of the root 7. So 1 multiplied by this means it remains the same. And for the denominator, we'd have 3 minus root 7 multiplied by 3 plus root 7. The numerator remains the same again, it doesn't actually change. I'm going to change colour for the denominator. So now we've got 3 times 3 is 9. 3 times plus root 7 is plus 3 root 7. Minus root 7 times 3 minus 3 root 7 minus root 7 times plus root 7 is minus 7. So this gives us 3 plus root 7 for the numerator again, plus 3 root 7 minus root 7 cancels out, so that equals 0. And then we've got 9 minus 7, which equals 2. So hopefully you had the same answer. If not, then rewind and go through my explanation of the solution again. So hopefully this has been helpful. If you have any comments, then please leave them below.